All right. Well, thank you for viewing the video today. My name's Hunter Frame. I'm field crops agronomist for Virginia Tech. We're here looking at cotton board studies today that are Virginia cotton board funded studies that we're conducting this year in the cotton agronomy program. Right behind me, the study right behind me is a brand new study that we started in 2020 that we call it the Predict In study. And what we're talking about when we talk about Predict In is predicting the nitrogen rate using remote sensing in real time. So we're coming in this plot behind me. We have different nitrogen rates that we put on, but we also have plots in this study where we're remote sensing with different sensors that can compute normalized difference vegetative index, and then we're predicting what nitrogen rate we need to have based off of nitrogen rich strips. So here behind me, directly to the left of me, this is our check plot. We're in Sussex County at one of our locations here on the farm of Bob Rogers, and this is following peanuts on a fairly heavy soil type, and this has no nitrogen. So if you look at this plot, and I'll step into this plot, you see the pale yellow color versus the plot to my right, which is darker green color. So this is no nitrogen. Still, we have really good growth on this crop in terms of development. But if we start looking at boll load and fruit development here, and I'll pull up a plant here so we can see this, we see we have a lot of missing positions where the crop has aborted fruit. We actually have a total of 1, 2, 3, 4, 5 bolls on that plant. So that's a total of about 15 bolls per row foot. We planted about 3 seed per row foot here. A lot of missing positions on here. Plant relatively, it's a little bit above my waist, but it's showing pale yellow. If we come down the next row, and I'm standing in the middle of 2 plots now, we have the nitrogen check versus what we would call our liquid grower check. So in this plot right here, this is our liquid grower check, and we have 120 pounds of nitrogen, applied. Not a lot of height difference, a little bit, about 6 inches taller if we look at that. And then we start looking at the fruit load here. We have 1, 2, 3, 4, 5 harvestable bowls, so not a lot of difference in the bowl load like we would anticipate seeing. Some missing positions here, but again, we see darker green color at this plot in our fertilized versus unfertilized plots. As we move down, we're going to come into the next set of plots here, and these are our nitrogen rich strips. These strips are to calibrate NDVI for our location, and what that means is every time we come out and remote sense, we read these strips, and these are supposed to be our healthiest strips in the field, our healthiest plots in the field. Should be our darkest green, have the most growth, because nitrogen has not been limiting in this plot. And we take the difference between these strips and the plots that we have out here that are regularly fertilized, where we're predicting nitrogen rate, and we're going to compare that to a nitrogen ramp that we have in this field. And we'll show a little bit more when we get back to Tidewater. We're going to splice a video together, but show you a little bit more about how we sense those. We'll have our sensors there. But what we do is we take the difference between this plot, a regularly fertilized plot, it received 50 pounds of nitrogen at planting, versus our regular 25 to 30 pounds, and then a total of 165 pounds of nitrogen total during the growing season. And we take that difference, we compute a nitrogen rate based off a modified algorithm we're using from Clemson University that matches more of our area or more of our climate. And so we'll get down and we'll just scan this first row here, and we're looking at these plots. Here we're getting into our nitrogen ramp. So now we're in our nitrogen ramp. So this is 40 pounds, and if we take a step back, you can see right down these 2 rows, darker green, fertilized, lower nitrogen rate here. So we have a lower nitrogen rate, 40 pounds. We'll move on down. This is broadcast, so not only are we comparing nitrogen rates, but we're also comparing broadcast versus liquid systems. So this is 40 pounds broadcast. We have 80 pounds broadcast here. You see it gets a little darker green. Come down, 120 pounds broadcast. This is urea ammonium sulfate. Moving down, this is 160 pounds broadcast system. So these 4 rows, 160 pounds. You see the height doesn't difference. We've been managing, so one of the things that we also look at in terms of nitrogen rate is how growthy does the cotton have, or cotton's going to get. And what we're seeing is we're able to control the growth. And if you look across this field, we have nitrogen rates that have been predicted all the way up to 180 to 200 pounds of nitrogen to the acre. So our growth has been fairly well kept using PGRs at our current recommendations. So we just moved out into the liquid nitrogen ramp. And again, you see it's a little bit yellower in color between the 160 pound broadcast and the 40 pound liquid. This is 40 pounds of liquid. Again, good growth on it. Liquid tends to be more efficient in our systems. This is 80 pounds in the liquid using a liquid side dress system. 120 pounds liquid side dress system. And then finally we have our 160 pound liquid side dress system. And then we start getting into our predicted end rates here, and where we're using handheld versus our UAV platforms. And we'll talk a little bit more about that here in a second once we get back at the Tidewater location. This is one of 3 locations that we have of this study. So we have this study here following peanuts on a heavier soil texture in the western part of the growing region in Virginia for cotton. We have a study in the Newsome's area where we're looking at this on a sandier texture soil following peanuts. And then we have our site at the Tidewater following corn, where we're, and again, same treatments, but we're following corn, and it's on a fairly productive soil type, and we'll show you that site here in a few minutes. Thank you. Okay, so now we're back at Tidewater, and we're going to talk a little bit about the Predict End site here. This is the second site out of 3. We've covered the site, or we've looked at the site in Sussex. Now we're looking at the site in Suffolk. We're not going to go over the site in Newsome's, but that we have another location down there. I'm going to talk here in a little bit. We'll go see the actual cotton, but first I want to talk about our remote sensing, or what do we do to remote sense this cotton to be able to predict the nitrogen rate. So here we have our UAV that's flown at 5, 6, and 7 weeks after planting, and this flies on a set route across the field. And then we take the images from this multispectral camera here, and we process them on a computer in a software that computes normalized difference vegetative index for us. And so we can differentiate between lighter yellow plots and darker green plots to a more fine-tuned level than our naked eye. And so here we have our Alta multispectral camera, and this takes, you see it has multiple lenses. If we get close, we have multiple lenses here, and it takes 6 pictures every time that it snaps an actual picture. So if you're taking a picture with your camera, you get 1 picture. Every time we take a picture with this, it takes 6 pictures, and it takes pictures every so often as the drone flies over the plots. We take those images and we stitch them together so we get a map of the whole field, and then we go down and we look at individual rows. We compare this with a handheld sensor that gives us the same data. So we're actually walking, and there's a video on my Facebook, Virginia Cotton Production Facebook page, of our summer help walking and taking NDVI readings with a handheld. The handheld is a much cheaper, much more economical option than the UAV and the camera platform. However, we can fly a lot larger acreage and sense a lot larger acreage with this platform than with the handheld alone. And so that's the basics of how we capture these images to be able to predict nitrogen rate on these test plots. So now let's go over to the field and let's look at some cotton and some nitrogen predictions. Okay, so we're standing in front of the Predict End study here at Tidewater Agriculture Research Center, and we just showed you how we go about imaging the crop fields. Standing behind me, this is the Predict End study, and as you can tell, there's a definitive difference between the Rogers location and this location in terms of plant height, growth, vigor. This is a nitrogen check plot, so no nitrogen was put on this at all this year. And as you can see, it's very short, knee-high, yellow, row closures not even occurring here. So short stunted yellow cotton, no nitrogen. This is behind corn. You can see the corn residue laying on the ground. Not behind peanuts. Just gives you a difference in just in terms of crop rotation, the nitrogen availability from field to field, but also the availability of nutrients when you get timely rainfalls. The Sussex location has had timely rainfalls, much more rain than what we have here at Tidewater. And you're going to see, even as we move over to the fertilized plots, and this is the broadcast agronomic control plot. So this has had 120 units of nitrogen to the acre as a urea ammonium sulfate blend. You see darker green, but it's still shorter. We haven't had any substantial rainfall until the hurricane has come through this year, and this is really, we've limited the amount of picks because the water was limited. This cotton was wilting daily from end of June through the first period in August. We've gotten rain now, however, we still have, it looks like, quite a bit of high fruit load on this crop for as short as it is, and the limited rainfall that we've had. This is the this is the liquid agronomic control here. As you can tell, a little bit darker green. We typically will see a little bit more of a darker green color and a little bit more vigorous growth with liquid versus dry formulations of nitrogen. And then the next two plots that we have here are our nitrogen-rich strips. So these have had 165 pounds of nitrogen on them, and those are what we look at and we compare to the other plots in terms of what does it need to look like in terms of growth. And so we have a dry, which is behind me here, a dry granular, and then we come, and this is our liquid nitrogen-rich strip. So this is what, again, what we compare in order to make nitrogen recommendations. And then just like at the Sussex locations and Newsome's locations, we have nitrogen ramps going from 40 pounds all the way to 160 pounds into the acre. So what does that look like? What I'm going to get into now. So we got a nitrogen ramp so we can actually quantify what the nitrogen response is here at this location to kind of shore up the model for Virginia that we're going to develop off of these three studies, and then look at that model next year that we develop based off of this preliminary data. So what does it look like in terms of nitrogen recommendations using the modified Clemson algorithm? And I have a paper here, some cheat notes. So if we looked at the Sussex location that we just looked at this morning, the side dress nitrogen prediction, the minimum amount of nitrogen we put on, that we predicted to put on at that location, was 77 pounds of nitrogen to the acre. The maximum was 135 pounds of nitrogen to the acre at side dress. When you add 25 pounds of that, what we had in our pre-plant fertilizer or starter fertilizer, the total N rates range from 102 to 160 pounds of N predicted to the acre, with an average of 135 pounds of total nitrogen at that location, and that's following peanuts. If we looked at the differences in time, so we read these at 5, 6, and 7 weeks after planting. We had 5 weeks after planting, we predicted 97 pounds of side dress nitrogen, 6 weeks 113, and 7 weeks 122 at the Rogers location. There was a slight difference, about a 15-pound difference between granular and dry. Granular resulted in a predicted N rate of 118 pounds versus the liquid average, which was 103. When we come here to Tidewater, this is this location. Behind corn, not as much residual soil nitrogen. What we saw was, for side dress N rates, the minimum predicted side dress N rates, whether we were using the drone or the handheld device, was 107 pounds of nitrogen to the acre. The maximum side dress N rate was 160 pounds of nitrogen to the acre. That's well above what we recommend. This is a highly productive soil, holds moisture, holds nutrients. I think that's over applying, but that's what the model predicted, so that's what we put on. The mean side dress nitrogen rate was 142 pounds of nitrogen to the acre. So we had total nitrogen rates, this season long when we add in starter nitrogen or pre-plant nitrogen, range from 132 total pounds to 189 total pounds of nitrogen based off the model that we were using. How does that look between granular and liquid systems, they're about even. There's only a 5-pound difference. When we go to the Drake or the Newsome's location, where we had a sandier soil, it did follow peanuts, but we had a much sandier soil at that location. That's where we saw our greatest differences between dry and liquid systems. Well, the minimum nitrogen side dress rate at the Drake location was 61 pounds of nitrogen to the acre. The maximum side dress in application that was predicted in our model was 176 pounds of nitrogen to the acre, and that was with a granular system. So the total nitrogen that we actually put on, in terms of what we put on at planting and side dress, the minimum amount of nitrogen we predicted there, total nitrogen, was 132 pounds of nitrogen to the acre. The maximum was 189 pounds of nitrogen to the acre, with an average of 167 pounds at that location, or 138 pounds at that location, sorry. The huge discrepancy, or the big difference there that we saw, was when we looked at liquid systems. The average side dress N predicted with the liquid systems at that location was 81 pounds of nitrogen to the acre. With the granular, the average side dress nitrogen application rate was 148 pounds of nitrogen to the acre side dress. Now you say that's a big discrepancy, but actually when we look at our placement studies that we've done the previous 3 or 4 years, we see that discrepancy where our optimum N rates with the granular system are actually around the 180 pounds of nitrogen rate. So we're not too far off in terms of what we've seen in past research with this model, which makes me believe that maybe this may be some of the area we're covering. However, I do think on some sites, like the site here at Tidewater, their model is over predicting nitrogen, and that's where we have to adjust that to take into account early season crop growth with the nitrogen we're applying early. So that's a little bit about the Predict N study, a little bit about what we're seeing here. Thank you for your time, and this is just one of the projects, one of the sites that the Cotton Board's funding in 2020. Thank you.